To design a complex software application efficiently, the application can be decomposed into a set of manageable chunks called microservices. For instance, an online shopping application can be decomposed into several microservices such as user authentication, product selection, and payment processing. These microservices can be executed independent of each other by a mobile or web application through their APIs. Different teams or developers can work with each microservice independently or in parallel. Moreover, these microservices can be encapsulated into Docker containers, and such containers can be uploaded to an online registry. Now to run the application, we can use a cluster with Kubernetes which can consist of one or several worker nodes. Each node can contain one or more pods. Each pod runs one or more containers, where each container can run a different microservice. Moreover, each pod has a control layer that consists of a container runtime, a kubelet, and a kubeproxy. The kubelet can decide which pods to run on the node. The container runtime runs the containers on the worker node. It is responsible for pulling the container from the registry, starting and stopping the containers, and managing the container resources. Kubeproxy is responsible for routing the traffic to the correct pod. It also provides load balancing to make sure that the traffic is evenly distributed across the pods. The cluster also has a control plane which controls or orchestrates different worker nodes based on their available resources and the current load on the cluster. The users can communicate with the control plane through a user interface or a command line interface. Kubernetes is highly scalable. It can scale an application up or down if needed, allowing us to respond to changes in demand quickly. It is also highly portable, meaning that we can run it on different clouds or platforms easily.